Thanks, Jeffrey. I'm Mia Kitahara with Stop Waste, and I've had the pleasure of working with Bayron since its inception. Something else that I do at Stop Waste is monitor or follow what our cities are doing in their climate action planning. So in that context, as they're looking towards 2020 and beyond, we're moving away from just needing to do incremental 15-25% improvements to energy efficiency and really going to zero carbon. And that's kind of the metric that they're looking at. So then we need to ask the question, what does that mean? And I'm so fortunate to be joined by these experts here. Thank you so much for joining us to talk about that and give your technical expertise. I think we'll be talking about energy, materials, and carbon, which are kind of things that have been siloed to date, but we'll discover that they're really interdependent and that our energy efficiency choices have material impacts, and our material choices have energy impacts globally, and that they all have a carbon impact. So how do we, it's going to get a little complicated, I think, but we're in good hands here, and we'll have plenty of time to digest it afterwards, after the break, when we break into our discussion groups. So I'm going to introduce, I'm going to do a little bit of your bios now. The sequence is going to be that Larry Strain will introduce this concept of zero net carbon and give us an overview of the energy materials carbon nexus. Larry is a founding principal at Siegel and Strain Architects in Emeryville, a 20-person firm with a focus on community projects and sustainable design. He's a member of the AIA Materials Knowledge Working Group and serves on boards of the Ecological Building Network and the Carbon Leadership Forum, is a chair of the Reuse Task Force of the Embodied Carbon Network, and was on the research team for the Embodied Carbon benchmarking project. So he's well steeped in this. For the last decade, he's focused on building reuse and reducing the total carbon footprint of buildings. And he's authored specifications, studies, white papers, and more on this topic. And then we'll hear from Bruce King about how to apply some of these concepts in new construction. And Bruce is the author of The New Carbon Architecture. He'll talk, I think he'll show you a picture of that book and 3 other books. He's been a structural engineer for 40 years, designing buildings of every size and type around the world, from Port-au-Prince, that's really shameful that I can say that, to Palo Alto. Port-au-Prince. He's also the founder and director of the Ecological Building Network, a nonprofit information resource that puts on the BuildWell conferences and hosts the BuildWell Source, an online user source library of low carbon building. And then after Bruce, we'll hear from Nick Durr about efficiency upgrades to existing buildings. Nick is with the Association for Energy Affordability. Any of you familiar with Bayron and the multifamily program will know AEA and may know Nick directly. They do our technical assistance for our multifamily program, and they've been great at it. At AEA, Nick is the director of programs, and he's responsible for multifamily energy program implementation and oversight of technical services. He has a decade of experience collaborating amongst stakeholders in comprehensive multifamily energy retrofits, including building owners, utilities, government, property owners, building operators, engineers, architects, and contractors. So he speaks all their languages. So again, I'm so pleased to have this panel, and I'm going to stop talking now and turn it over to the experts and get your slides going.
All right, good morning. Nice to be here. This is, I'm not used to speaking to people who actually know a lot more than I do about energy efficiency, so I have to I can't fake it here. So let me see here. Okay, here we go. So I was told I would be speaking about energy, materials, and carbon, and I'm really going to focus everything through the lens of carbon. That's what I've been focused on for the last 10 years, is looking at all of those things through that lens. And so we're really going to talk about all the emissions, and we're focusing on the built environment. That's our specialty. We're not talking about transportation and stuff like that right now much. But we're going to focus on all the carbon emissions from a building throughout its life cycle. And I'm also going to talk a little bit about the time value of carbon. Given where we are right now in our climate problem, we have a limited time to deal with this. So my point of view is that every decision we make around carbon reduction has to have a time component to it. You can't look at solutions that are 50 years out anymore. It's no longer relevant. What else am I going to talk about? I'm going to talk about existing buildings and why I think they're really the key to solving this problem. And then Bruce is going to dive deeper into embodied carbon, and Nick's going to talk about energy efficiency through the lens of carbon. So we'll take it from there. So time value of carbon. So this is sort of what we've got to do. We're trying to keep the temperature from rising above 1.5 degrees, and we're actually pretty close to that already. We would like emissions to peak by 2020, which is less than 2 years from now, almost a year from now. And fossil fuel phase out by 2050. And 2020 in May is more important to me. It's like when those emissions peak and start to drop, and how fast they drop is really, really key here. So we need carbon saved now. Now is more important than later. And we need large reductions now. And because some reduction strategies come with an initial embodied carbon hit, we need to actually look at the net carbon savings over the next 10 to 20 years. It's not the total carbon savings. It's a renetting a savings, or it's probably not worth doing if we're not. So this is a little chart that illustrates this time value of carbon. So the blue line shows 10% reduction every year. The red line shows kind of starting out slowly on carbon reduction strategies, and then as we start to panic, increasing the rate of reduction and getting to zero. These all get to zero. The green line shows starting out fast, and then as it gets harder and harder, maybe we back off a little bit, we get to zero. The area under each line is the amount of carbon emitted over time. So the faster we start, the faster we do things, the less carbon, total carbon is emitted between now and 2050, or now whenever we get to zero. So it really makes us look for front-loading our carbon savings, not looking at long-term, the old 7 generations thing. We got 1 generation now. We don't have 7 generations to solve it. So, buildings are the largest contributor globally to carbon emissions. Operating emissions are the largest piece of it, but there's embodied emissions are over 10% globally of all emissions in the world. And usually, this in the Bay Area, this pie chart's a little different. Transportation's bigger. Embodied carbon, I don't know where embodied carbon is, but the whole building sector is probably smaller. Transport's probably a little larger in the Bay Area. But nevertheless, globally, this is where we are. And usually when we think about reducing carbon emissions, we focus on building emissions. We focus on operating efficiency, which is the biggest piece. So it's good we're focusing on that. But if I go up and down here. Oh, I see over here. Well, maybe I'll just read the first part of my notes instead. But the embodied emissions are actually a huge piece. And the reason they're so important is they're the emissions that happen first in a building's lifespan. So if you look at a building's lifespan, those emissions happen right off the bat, and then operating emissions happen over time. So they're the most important emissions. In my book, they're the most important emissions to try and reduce. The other thing to keep in mind is that the embodied emissions come from what we build every year, which is about 5.5 billion square meters globally. And it's about 11% of our emissions, about 4 gigatons of emissions. Operating emissions happen from all the buildings we already have, by definition. They happen from a building that's already built. And that's 230 billion square meters. So the amount of emissions per square foot is much higher for building a building than for operating a building. We probably already knew that, but that's important to remember. So how do we get to zero? How do we get to this point of, in the next 10 to 30 years, but really in the next, 10 years is what I'm focused on mostly. So architects think about getting to zero this way. We love making new buildings. We want to make new net zero buildings. There's lots of programs to encourage that. So we focus on making new net zero buildings. We're beginning to think about reducing embodied carbon. There's a lot of stuff happening in the AIA, starting to focus on this, and it's really important, and it's a huge piece of it. And upgrading existing buildings is not on architects' radar. It's on cities' radars, but it's not on architects' radars very much. They'd rather build a new building with net zero and talk about how great the building was. So I think we've got it backwards. And here's why. Those new buildings we're building every year emit about 400 million metric tons of carbon to operate those new buildings, that many new buildings. If they're average efficiency, if they're more efficient or net zero, that number goes way down. To build those buildings, it's about 4 billion metric tons to build that much every year. And to operate what we already have is 10 billion metric tons. So we're focused on this thing on the left as architects, and we should be focused on the thing on the right and the thing in the middle. So really, we should be talking about upgrading existing buildings to zero, reducing embodied emissions. Making new buildings net zero is great, but it shouldn't be our primary focus, really. I mean, any new building we build should be a net zero building, and that's not to say they all are, for sure. There's an awful lot of buildings going up around us that are maybe energy efficient, maybe green buildings. They're not net zero, most of them. The other thing that's going to help us on this whole thing is the grid's getting cleaner. So as the grid gets cleaner, even if they're not net zero, you start to pull off a cleaner grid and the emissions go down. So that's in our favor, which is good. So here's a little project which some of you may know. It's the DPR office buildings in San Francisco. It's a net zero. It's actually a net positive remodel. It's the offices for DPR construction. It's not our project. We didn't design this building. We did the post-occupancy study after it was done. And they had achieved a net positive building, and we came to them and said, how would you like to know how much total carbon this project emitted to build it and to operate it? Look at the whole thing. And they were really interested, so into a group who was the mechanical engineer for the project and our firm looked at the total carbon emissions, and we used a thing called Tally, which is a Revit plugin, which lets you look at all the materials in your building model and calculate the carbon impacts of those materials. And what we found was that reusing and upgrading an existing building was a really great strategy for reducing both embodied carbon and operating carbon. So here's what the different materials looked like. It ended up with about a 70% reduction in embodied carbon over building a new net zero building. All the hatched lines are materials that were reused, and all the solid lines were materials that were added to the building, to the project as we went. And then Tally didn't have a way to model the PVs and the mechanical systems, and so we modeled those separately, and it about doubled the embodied carbon footprint of the building. But since those are the things that make this a net zero building, and the payoff is about 4 years, they're worth doing, even if you double your embodied carbon. And the payoff's quick. If the payoff was 30 years, they might not be worth doing, but it wasn't. So if they did nothing with this building, just left it alone, it would emit about 5,000 tons of carbon per year. I mean, over 20 years. That's the carbon footprint of this building over 20 years. If they built a new net zero building, the only emissions would be the materials, which is about almost 1,000 tons of emissions to build it. And what we did was the materials went down by about 70%. The electricity, this is a net positive building, so the total emissions over 20 years was 150 tons versus 5,000 tons from doing nothing, or almost 1,000 tons for building a new net zero building. So it just is a little illustration. This was actually the 20,000 square foot, 2-story building, didn't have great orientation. The only energy efficiency upgrade they did at the envelope was the roof insulation. They had an historic aluminum curtain storefront window that they couldn't touch because it was historic. So it was a single glazed aluminum curtain wall. They didn't need that, and they still got to a net positive building. And they did this on a $160 a square foot, so they're basically a very competitive remodel budget. And there's a whole lot of 2-story commercial buildings across this country. Almost all of them in every climate zone except maybe Alaska could go to net zero. It's doable. It's not like impossible. So that seems to me where we should be focusing our energy. We can tear them down and build new net zero buildings, but there's a huge carbon hit for doing that. All right, so what about new buildings? We're going to keep building them. We still need them. And if we're going to do it, they should be really efficient, ideally net zero. So this just sort of shows standard emissions, efficient building, and which efficient meaning probably better than code, and then net zero operations over 20 years. But as we say, there's that big carbon hit at the beginning that happens before the building starts operating. So over time, those are the biggest emissions. Over 20 years, typically it's going to be about equal to the emissions from a standard operating a standard building. So let's look at where those emissions are to understand embodied carbon a little bit. Bruce is going to go into this in a lot more detail, but I just wanted to give you an outline. So materials account for about 75 to 85% of the emissions, the embodied, what we call embodied emissions. So it's the site work, it's the materials, it's transport, and it's the construction equipment to build a building. 10 minutes, okay, great. And most of the emissions from those materials is in the structure, followed by the envelope, maybe interiors, MEP systems, but a lot of it's in the structure. So we really want to be focused on structure. So let's look at how that breaks down. So large, heavy buildings, which is typically commercial buildings, have about a double, 2 to 3 times the carbon footprint of a small light building like a residential building. And it's mostly the kinds of materials we use and the quantities we use. So small light buildings are typically wood frame. Maybe they're even light gauge metal, but wood frame. And it breaks down that most of the emissions in the big building are in steel and concrete in the structural frame and foundations. Even in the small building, a lot of it's in the concrete because they all have a concrete foundation. So that's typically the biggest. But even wood has a carbon footprint if you just count the energy and emissions it takes to process the wood and harvest it. I'm sorry, mechanical, electrical, and plumbing. I'll explain acronyms and now I'm going to forget them. So anyway, CO2, I assume you know, but MEP. Yeah, so this is given in kilograms per square. So it's a big difference a big range for big buildings, 200 to 1,200 kilograms per square meter to build it. It can be a lot. I think the average is probably at the lower end, but some of these really big buildings actually have a bigger carbon footprint typically than smaller buildings per square foot, which is interesting because the structure gets so much heavier to build those tall buildings. So there's other reasons to build big buildings. You build them near transit. You reduce transit emissions. So there are good reasons to build tall buildings, but the building itself is worse than a small building on a square foot basis, just so you know. So, and then small buildings, it's in the wood, concrete, and cladding mostly. And there's ways to reduce it. One is we can be efficient. We can be more efficient. We can design smaller buildings or design more efficiently and use fewer materials, and we reduce the carbon footprint that way. We can also use lower carbon materials, and this is something that Bruce will get into a lot more than I will. Using carbon materials that have a lower carbon footprint or even a net positive. They're actually sequestering materials. And the other way is one way to use lower carbon footprint materials is to use salvaged materials. They have a lower carbon footprint than new materials almost always. But there's another way to do this, which is to reuse the whole building, which is what the DPR office building did. So the carbon footprint of that is like less than half usually of what a small residential building is. And typically, most remodels, most of our remodels don't replace the structure. The structure stays. So your biggest carbon footprint stays. It's already been emitted. You don't have to worry about that. You're not replacing that. Sometimes you do a seismic upgrade and you add some steel, but it's not the same as putting in a whole new building. So this is a great way to do it. So this thing that I showed you earlier isn't actually quite accurate because it looks like there's the carbon emission, the embodied emissions, and then there's the operating emissions, and they're not connected. And they're actually connected. The embodied emissions happen first. And you don't even start using the operating emissions until those embodied emissions have already happened. So the idea is those emissions are with you. You never get those back, the embodied emissions. You can't be efficient in reducing those over time. So the first thing you want to do is to lower the embodied emissions. And you can do that through the renovation project probably cuts it down by 70%. So you're starting from a much lower point before you start operating your building. And if you're net zero, then the whole footprint is just that smaller renovation budget, or as Bruce will get into other ways to get this down. So I'm going to turn it over to Bruce to talk more about, there he is, embodied carbon.